Hi, Jesslyn. How are you?
Hi, Roopesh. I'm good. How are you?
Good, good. So, did you have a chance to practice that topological link prediction?
Yeah, I've done for all six, but I was not able to upload it on the Google Drive. I
Huh?
believe I'm not. I don't have the access to make a folder and upload anything.
Was it? Okay, let me have a look about it. Yeah,
Yeah,
no
but
worries.
I've done all six. I've tried all six, and it works.
Super, very good. That's fantastic. Yeah.
Thank you.
So, hello everyone. Welcome to Seda Lighthouse Project Season 2. So, once again, welcome to our brand new course on like power of graph neural networks, mastering graph-based machine learning. So, myself, Roopesh Bharatwaj here. So, I hope like you had like a wonderful weekend, and let's start with our course today. So we are in our fifth class here. So let's begin with the recommendation systems for this week. And before that, let's do a small recap of our previous sessions, what we have done so far. So in our last lab session, we were asked to do like 20 different nodes and edges. And once we done that, we started with like a topological link predictions. And basically like you all know that link prediction is like it finds like closeness of each and every nodes and their neighbors. I hope like you all would have done like six different algorithms, and we started to discuss upon like different types of algorithms available in Neo4j pipeline, like admic cadar, common neighbors, preferential attachment, resource allocation, same community, and total neighbors. So in our last session, our task was to like utilize the topological link prediction algorithm for our personalized graph, which we developed in our lab session, and to compare and contrast the six different algorithms and to upload the same in our Google Drive folder. So I have seen like a couple of people have uploaded in our folder, and let's take it forward on today's class, and our next lab session we can discuss it furthermore. So in our today class, so let's gonna discuss about like a different types of like recommendation systems and examples of recommendation systems, their applications, and a brief introductions of recommendation systems. So let's start with our recommendation systems. So recommendation systems is a technology that suggests products or services or contents to user based on their preference and their behavior. And for this, there are like several different types of recommendation systems available in our current pipelines. So they are collaborative based filtering, content based filtering, hybrid system based filtering, context aware recommendation systems, session based recommendation systems, matrix factorizations, hybrid systems, factorization of machines, temporal and sequential models, and finally the reinforcement learning models we have. So in this different types of our recommendation systems, we have only like five different types of our models which can be used to apply for graph convolution networks. So they are basically like collaborative filtering one we can apply, context-based filtering we can apply, hybrid systems we can apply, the context-aware recommendation systems, and session-based recommendation systems. So in our class, we'll be discussing about the first four different types of recommendation systems and we'll be like going into a bit deeper about each and everything with examples and their use case applications. So let's discuss a bit detail about like different types of recommendation systems. And now let's start with our collaborator filtering. So the collaborator filtering relies on the idea that a user who have interacted with or liked similar items in the past will have a similar preference in the future. So that's the main idea of a collaborative filtering. And basically, there are like two different types of collaborative filtering we have. So they are like user-based collaborative filtering and item-based collaborative filtering. So now let's take an example here. So of a user-based collaborative filtering. So this method identifies the user with a similar behavior or preference and recommends the item that those similar users have liked or interacted with. So here, let's take example of Mary and Aaron love story. So here, Aaron likes shirts, jeans pant, and his cap. And Aaron's wife Mary, she likes the same like shirt, t-shirts, jeans, cap, and she also likes like sneakers. So now the based on the user, Aaron may also like the sneakers. Why? Because he's connected with his wife Mary, and Mary's preference and Aaron's preference are closely matching together. That's why we call like a user-based collaborative filtering in this example. So similarly, let's talk about the item-based collaborative filtering. So in item-based collaborative filtering, instead of focusing on similar users, this approaches looks at the similarity between the items. So for example, if a user has liked or interacted with a particular item, the other items that are similar to it may be recommended. For example, here, Aaron likes t-shirt very much, and Mary likes the t-shirt very much, and Jesse likes the t-shirt very much, and Steve likes the t-shirt very much. So here the similarity between the t-shirt and the hoodie. So the most of the people and the items are being liked by each other. So Aaron may also like the hoodie as he likes the t-shirt as well. So that's the context between the item-based filtering which is applied here. So the next one important thing is like the problems which is being faced in like collaborative filtering. So in collaborative filtering, there's like a problem called cold start problem. So basically, a cold start problem is that it tells like when there is a user who does not have like a historical like a data which is being used here. So that's the important point here where like our user does not have clear data of historical events. That's called as like cold start problem. In cold start problem, there are like two different types have been here. For example, they are like a new user cold start problem and new item cold start problem. So new user, as we earlier know, like what's the difference between like user based filtering and item based filtering. So new user, that means like there is no enough data about like users currently being used here. And similarly, it has the example of item as well here. To how can we overcome the problem of collaborator filtering? So there are like three different approaches to overcome the collaborator filtering problems. So they are like a content-based recommendations, hybrid approaches, and contextual informations. So these are like three different types of our models, which we're going to be discussing further. So based on them, we can overcome with our problems. So let's dig big about like about content-based filtering. So content-based filtering is a type of recommendation system that it able to give each user a very personalized item recommendation system. So here, they're based on the different content. So we will be giving our recommendations here. So let's take an example. So now in this example, we are aware that Aaron, who wants to watch movie called Marvel. So he's been used and like this data has been saved here. So now the Marvel, that's our content based filtering will be like digging more about his similarity of that movie like Marvel. So similarly, he has a like in the content based filtering will give a recommendations that he can also watch a Batman movie here. So that's how the content based filtering works based on the different context which a person is being used and how it's being utilized in terms of like the recommendation to another person. So why the content based filtering is better? Because like the content based filtering is like has an edge over other based filtering because it does not require any people or personal data. So all it requires is based on your data on your preferences. That's the main goal of like content based filtering. So now let's talk about hybrid systems. So basically, the hybrid system is a combination of both content-based and collaborative-based filtering. So it is a special system which simulates the users and the suggestions based on the collaborative filtering and content-based filtering, and it gives a personalized recommendation system on overall. So in the system, the each user presents the similar items already used by a user or suggested items which are likely to be used by another user with similarities. Based on the similarities, now the recommendation system combines those informations and feeds to a front end or like a backend system, and that's how we will be getting a recommendation that a person likes this very much, like a user likes this content very much or not. So now let's talk about like how hybrid system have an edge over collaborative and content based systems. So in this collaborative and content based system, it has like very important properties here. So it is based on improved recommendation accuracy. So by combining the different recommendation techniques, a hybrid system can potentially provide more accurate and relevant recommendations, and it can compensate for the weakness of individual methods and enhance the overall performance. That's the biggest advantage of like improved accuracy here, and which is like far better in terms of like our collaborative and content based filtering. So here we are mitigating a biggest problem called cold start problem. As I said earlier, the cold start problem is which occurs when there is a limited or no historical data for new users or items. By using content-based recommendations, the new items and collaborative filtering has been established by the system, providing relevant suggestions. That's the biggest edge over hybrid systems when comparing with the collaborative and content-based systems. And our next important thing is like it has like a diverse recommendation system. Here why we say like a diverse, because it includes items that may not have been surfaced by a single approach. It can be lead to like a much more diverse in terms of like potentially leading to a higher user certification and like a difference of a different experience, and like a quality of experience and the certifications can be possible using diverse recommendation system options. The next important thing is like robust to sparse data. In a situation where the data sparsity is very challenged, the hybrid system can have particularly effective here. For example, the collaborative filtering may struggle with sparse data, but in combining with the content-based filtering, that is called like a hybrid systems, it can provide much more reliable recommendations, and it can adapt to different scenarios and like in a more or large data sets as well. The next biggest edge over like a collaborative filtering, content based filtering, is the user preference. So different users have a different preference and their taste and their behaviors. A hybrid system can adapt to these variations using a combination of techniques, ensures that recommendations are tailored to a wider range of user profile and not into a single perspective or single person perspective. That's the biggest advantage in a hybrid system. And next important thing is like flexibility and customization. In hybrid systems, which offers like flexibility in how different recommendation techniques are combined. This allows for customization based on the specific needs and the characteristics of the specific applications or specific domain purposes. So we can customize and tailor based on our specific set of goals and objectives. Enhanced the domain coverage. So here the biggest advantage is like the different recommendation system techniques may use different domains. By combining them, a hybrid approach can cover a broader range of domains and provide a recommendation system for a wider array of content or products. Domain in a sense like the different perspective like e-commerce, like hotel managements, or like travel agents, or like IoT devices, etc., etc. We can tell. So, and the biggest like edge is like it reduces the popularity bias. The popular items may dominate recommendations is purely based on collaborative filtering systems. By incorporating the content-based filtering, here our system alleviates the biases and surfaces less popular based on potentially relevant items, and thus it has like edge over hybrid systems. The next important thing is like it has like a better handling of dynamic environments. So for example, when a user preference or item popularity changes over time, a hybrid system can adapt more effectively. For example, if new items are introduced, in a content based filtering can help recommend them until enough collaborative data is available here. So here it can like it can tackle different domains of environments and different instances it can tackle it. The next important thing is like optimization of business and objectives. The hybrid system can fine tune to align with the specific business goals, such as maximizing a user engagement, increasing the sales, and giving increasing the promotion, or giving like a new like a discounts, or a specific type of contents, or a new product launch and everything. The optimization of business objectives serves a very heavy important here. For example, in our Amazon, if we take the, we'll be using like the recommendation based on our contents which we have purchased before, or products which we have purchased before. At a time of sales, we'll be having a page which shows us more likely to buy and more similar items to buy. That's is based on the completely the business objective. When this can be why I'm telling this example, because during a prime day sales, we can see that there's like much more in terms of our recommendations will be available rather than our normal sale day. That's the important thing here. They increased the objectives on specific purposes. So now let's discuss a bit about like different types of applications has been used in hybrid systems. So one example we already discussed was like Amazon one. So it's e-commerce platforms. So how the e-commerce platforms are being used here, let's talk about it. By combining a different recommendation techniques, a hybrid system can potentially provide more accurate and relevant recommendations. And moreover, it can compensate for the weakness of individual methods and enhance the overall performance. On, as I said earlier, based on specific occasions and specific set of products and items, it gives us our enhanced like recommendation systems based on content as well as like based on specific users. So next one example is we can talk about like movie streaming services. So the movie streaming services, for example, let's say like we have like Netflix or Amazon Prime. So hybrid recommendation system could incorporate collaborative filtering based on user ratings and the viewing history. And here, now we'll be using the content-based filtering as well, because we are gonna view the new movies, and movies in the sense like different kinds of genres, different kinds of like their attributes like genres, or like directors, or based on different types of actors. We offer a personalized movie recommendations. This approach can help a user with more satisfaction and encourage our users to continue the engagement with Netflix or Amazon Prime. This is the one of the biggest advantage using of our hybrid systems in movie streaming services. The next important thing is like our music streaming services. So in our music streaming services, so we can it has like as I said earlier, the same, it has like a very good properties. It has the hybrid recommendation system could incorporate the both the collaborative filtering based on user rating and number of viewing the songs history, historical data of like songs and their likes and their reviews. Here the content based filtering also being used here, in sense like what is the what is the context of the song, in a sense like their genre, the tempo, or the rock or jazz, or a different type of artist, or like classical or instrumentations. Here we have different types of combinations here. By using a hybrid recommendation system, which offers a more diverse and tailored music playlist to users, and it engages with their preference and past interactions. And here, our the most likely to like listen songs in future also comes based on our the liked artist or like liked music directors. Yeah. The next important thing is our new news content aggregation platforms. The hybrid systems are very useful for like a news and contents. Here, the collaborator filtering uses are like different types of engagement with our articles in our previous historical articles, what type of articles we have seen and everything. And here, the content-based filtering also works in the sense like what is the article tags? Are there like different kind of categories like fiction or novel, or like a latest trending news, or like a old news or geographical news or political news. This suggests the relevant news or articles and the contents to the user. So basically this approach will be used for like a personalized news experiences which can be gained to a user based on hybrid systems. So next let's look upon like social media platforms. So in social media platforms, hybrid systems could leverage the both collaborative filtering as well as like content-based filtering. In collaborative filtering, now so let's take example of a social media where a user interacts with another user, and like where he does like likes or comments or shares the post. Okay. Now we let's talk about the content based filtering. Now the in perspective of the content, what type of content is being viewed, and what is the hashtag of that a social media platform, or like what is the hashtag of the content which is being used, and what is the topic of the hashtags is being used. Now the both the collaborative based filtering and content based filtering merges together into form into a hybrid based system that gives us the approach, and that gives the most relevant post or the most relevant connections to the user. By this, the user gets like more engagement and like a more information discovery he does. The reading news articles also he does. That's the biggest advantages of like hybrid systems in our social media platforms. So let's talk about finally like travel and accommodation booking. So how can a hybrid system can be useful for like a travel and accommodation booking? Let's think about it. So we all know about like a collaborative based filtering. So where the different uses are being used here, and different platforms is there, different booking histories will be there, different hotel booking histories will be there, and hotel types also will be there, like 3-star hotel or 4-star or 5-star hotels will be there. And how a content based filtering can be applied for this, let's think about it. So the content based filtering in a sense like we can say about, we're gonna book a hotel in a place. So what are all the amenities are available in the hotel? So what is that city, and what is the price range of the hotel which we gonna stay? So that and all the information will be available in content based filtering. By combining those both collaborative and content based filtering, we can give a tailored suggestions for hotels, for flights, or travel experiences. So that's how our content based filtering and collaborative based filtering works here. So let's talk about the another option called the context aware recommendation system. So in context aware recommendation system, so it gives a broader perspective where where like it merges the different perspective of like collaborative filtering, content based filtering, the hybrid based filtering, as well as the environment of the context here. So say for example, how in the sense like let's say an example. So each user has their own taste and preferences. So that are majorly dependent on contents what they use in the different locations, or like what time of the day, or what influenced them the most, or what are the environmental changes they have in the process of recommendation system. So unlike the traditional recommendation system of content based or collaborative based, which uses like a two-dimensional data sets, here we will be using a context aware, like a third dimension. That third dimension will be based on the different environment that predicts the users. And the third dimension will be much more like useful in terms of recommending. Say for example, we can personalizedly recommend in the evening a person likes to drink like a hibiscus tea, and the same guy likes to drink a black coffee in the morning. So here the environmental is much more dependent. So that's the main context of like a context aware recommendation system. The context aware recommendation system are being used in like couple of fields, and like mostly in our latest technology, and it's kind of like a booming one as well. So here we will be using the entire interactions will be saved in a graph representations, and then the graph representations are of each nodes, and each the information are stored in like a bipartite graph. Once the bipartite graph comes, and next important step is like we'll be finding the nearest neighbor. The nearest neighbor algorithm finds how well the each node is another node is well connected with each other based on the relevant context and based on the relevant environmental perspectives of all three-dimensional perspectives. And then based on that our network which we train, we give like a list of recommendations. On this time, this person likes this hibiscus tea, or this person in the early morning, he likes to drink a black coffee. That's the example of a context aware recommendation system. So let's talk bit about it. So there are like couple of advantages for context-based recommendation systems. So one of the biggest advantage we can say is the personalization enhancement. In our previous one, like collaborative filtering or context-based filtering or hybrid-based filtering, we don't have that much like enough of like personalized engagement or personalized enhancement. We don't have it. But in context-aware recommendation system, we'll be combining all this information with real-time information of like locations or the environment, which are tailored to specific personalized users. So here the context-aware recommendation allows for higher degree of personalization, and that can be tailored for specific preferences and needs of each user in terms of real-time perspective. That's the biggest advantages of our context-aware recommendation system. The next biggest important thing is our improved relevance and timelessness. So context-aware recommendation system can provide suggestions that are more relevant to the users for the immediate situation. For example, a user needs to find a restaurant, and he needs to find the restaurant is either open or closed. Now the third dimension comes into place: the timings and the locations and the perspective, the what's the opening and closing of the day, or whether it's like open only for evening or open only for like a day. So that information are being utilized here to provide like much more effective informations for a recommendation system. So So the next important thing is like mitigation of cold start problem. So as we all aware about what's a cold start problem, let me give a small overview. The user cold start problem is like nothing but like there's no like prehistorical information of user data or like any other items. So here in contextual information can help alleviate the cold start problem where there is a limited historical data for new users or items. For instance, in a context aware system can make recommendation systems based on the user's current context. Even if they are a new user or like a first time like a user, the current situation based on them, it can be used and it can be further trained used based on the context which they are currently in. So next biggest thing is the diversity in recommendation. The context-aware system can offer a wide variety of recommendation system, ensuring that users receive a mix of options that cater to different aspects of the current context. This promotes a more engaging and diverse user experiences. So it does not even fix with like only one specific type of domains of recommendation. It can be applicable for like different types of scenarios such as like either it can be like e-commerce applications, or it can be useful for like a smart home applications, and it can be used for like IoT based applications. It can be used for health based applications, and with different domains of application, this context our recommendation system can be useful, and it has edge over our previous collaborative and the context based filtering and hybrid based filtering. The next important thing is like it is easily adaptable to the environments. As we all know that like the context based like recommendation system is like a third dimension one, which uses the location or time or based informations to map each other and gives the personalized recommendation system. That's what the same is here. So it gives the individual users set of behaviors, their patterns, their different types of use cases, their different types of like of environmental changes which they have, like, and each and everything, it is easily adaptable here. For example, the recommendations for users evening entertainment may be different, and for the recommendation for a daytime recommendation, that will be different. So in evening a person will be more likely to listen like some like a more classical way of songs, or the morning at the time he likes to listen more rock or jazz kind of music. So now this environment comes into play, as I said earlier. So it categorizes individual users, their preferences, their patterns, and their complete recommendation system is being studied, and then only the individual users, their perspective is being fed into our front end and back end system, and that's how the individual users will be getting a similarity of most preferred or most likely to listen or most repeated task or actions. So next important thing of context aware like recommendation system is like specified for specific goals, and we can train and optimize for like individual objectives of different business use cases and everything. For example, a retail app might prioritize recommendation based on the user's location to drive the foot traffic to nearby stores. Say we have like Uber Eats and everything. So now the app is being trained in a way that it needs to understand how the congestion is the road is. Based on the congestion of the road, it gives us a recommendation that where there is like a no traffic in a road, and automatically the driver or the Uber like a Eats driver, he moves to like a different path. Now here our context aware recommendation system is being used here because it's being trained on the current recommendations of different geographical locations and the like traffic location of traffic density of that road and everything. So that's how it is being trained for like specific use cases and objectives. So let's start to talk about like what are the different applications being used for hybrid systems. So one of the biggest application for hybrid systems are e-commerce and retail. So in e-commerce, the providing a location-based recommendations for nearby stores can be applicable, or like a special and different types of promotions can be applicable on different locations. Say for example, in Amazon UK, there will be like a different types of sales will be there, and Amazon in US, there will be different types of sales and promotions will be there. Here the different locations has been an important play here, and based on user perspective and user preferences on different geographical locations, it can be used here. So next important thing is like travel and hospitality. So the hybrid system is used for recommending the local attractions, restaurants, and events based on users current location and the time of the day. So it gives us like exact information based on our current location of a GPS location. It gives what are like attraction of interest within our close proximity distances, and what is like the specific day is like what's happening in a day is like football match or like rugby match or like is there like any food festival is going or not. That context based information can be applicable in travel and hospitality booking. So next important thing is like health and fitness applications. So in health and fitness applications, it gives us like a personalized plan or nutrition recommendation tailored to the user's location, their weather, and availability of the equipment. So, for example, if a user will be in like a more cold places or not inaccessible places, he needs to be have like the recommendation system that gives him like a proper way of utilizing the existing the equipment which we have and utilize that. So here the hybrid systems are much more useful here. So next, jump into different types of hybrid systems in news and context aggregation platforms. So as we know area like the providing a news articles or context content pieces that are relevant to the user current location or trends that are in a topic area. So each user will be given a personalized news information based on the geographic information. Either if he's going to live in Ireland or if he's going to live in UK, he's going to get a personalized information for like Ireland specific news and like UK specific news and weather conditions and weather report. So here the hybrid systems are being very useful for individual recommendation systems. So next important thing is like social media platforms. So here the each users or group or connections between a user is based on location preferences, and it is also based on the mutual interest at their musics or entertainments or like any other activities which they like to do perform very well. So that's how they connect to a friend or like find a friend with based on the similar mutual locations. So yeah, we can tell this as a good example. Say for example, if a user has been stored a person's contact information, so automatically this contact information with a mobile number, whosoever is that based on the geographic code of the mobile number, we'll be getting a personalized friend suggestion in our Facebook or Twitter or trends. So like he's more related to you and he's based on your contact information. So that's how the hybrid system is being worked here. So let's talk about like smart home and IoT systems. So in smart homes and IoT systems, so we can adjust that like lighting or temperature or entertainment based on user's preference mode or his different patterns or like his behavior based on the time of day or his based on his complete mood. We can optimize that. So again, here the different training is being carried based on specific task here, and that's so it's been used for like smart home and IoT devices. We can say example like Alexa devices, Siri devices, and Google Mini. So based on our like our speech or anything, it's automatically switch on the lights and it automatically controls the temperature systems. So finally, let's talk about like navigation and map services. So in hybrid system, which provides the real-time recommendations for routes, the transportation, and point of interest based on user's specific location and based on traffic conditions. So based on the traffic conditions and like and the geographic location, so each users will be given the optimized and most effective route of transport from one direction to another direction or one point to another point. And in the between, in mean time of the distance in their travel duration, our recommendation system also recommends the point of interest or like places of interest or for sightseeing and like most attraction places that also recommends. So that's how the hybrid system is being useful for our different use cases in our existing platform. So in our next class, we'll be discussing a bit further more details about the remaining types of recommendation systems, and we'll be doing our in-class demo. Yeah. So kindly let me know if you have like any doubts and questions, we can have like question and answer session now.
Hi, I have a question about the hybrid systems.
Yeah.
So, in hybrid systems, you said that we do combine the content-based and the collaborative filtering together. Um, is there like a sequence in which these two are merged, or does it happen simultaneously?
Yeah.
So, does the recommendations? Mhm.
So basically hybrid means like it will happen simultaneously. So why? Because so if a person wants to know about like what is the product, so he needs to look about like what is the item first of all, and next important thing he'll be looking about the reviews and the comments. So here the both collaborative and content based filtering is being applied, and thus it's called like hybrid, and simultaneously it is being applied.
So, for example, if I get like 2 or 3 recommendations based on the hybrid system, does it have like a weightage that is given to maybe give more weightage to a content-based filtering recommendation over the collaborative one?
No, it gives equal weightage and information. Why? Because that's it combines both of the information, not one specific high importance or one specific low importance. No, equal weight of importance.
Okay, I see. And I just had one more. In terms of context-aware recommendations, can we say that it is in a way like applying a filter on the recommendations itself?
Yeah, like we can say like we can apply on top of that filter, but
Yeah.
basically it's being trained with like a three-dimensional data. So in front end, what we see is like it's like adding on filter, but automatically it's being fed into 3D data. And in front end, we just for our use case and for our, like a friendly like a movement, we have like a filter option. That's what.
I see. Okay. All right. Thank you.
Yep. This class we'll be talking about like a bit more in detail about what are like remaining different types of recommendation systems being used and how GCN can be applied. And next session we'll be using our own personalized graph which you have developed, and we're gonna utilize a Neo4j like our recommendation system pipeline to build your own recommender engine, and we can see how the Neo4 can be applied in your graph.
That sounds good. Thank you very much.
Thank you very much. Thank you.
Yeah, sounds awesome. I'll try to catch up with the stuff that I have left with the graph so that I'll be ready for next time. Thanks, Rupesh.
Definitely. Like you can give me chat me a personalized so I can give you like a response or like tips and mentoring anytime. Yeah.
Awesome, thank you. Thanks.
That'd be great. Thank you very much.
Thank you.
Thank you, Roopesh. That was really great today.
Thank you very much, Jaydeep.
Hey Rupesh, how are you?
I'm good, Satatri. How are you?
Thank you, thank you. Rupesh, I have a question about not about this session, it's about last session. The first question is how can I access to the recordings of third and fourth, the class, because
Okay.
I couldn't see that.
Okay.
I,
So
I missed the class. Yes. Okay.
that's fine. Yeah. So our course like recordings have been like information is given in our SEDAR community page. So it's a link, Zoom session link is there with the password we have given. So it will be easy for you to access from there. Yeah. And the current session and our previous session will be information will be given after this session. Yeah.
Okay, because I couldn't find the third and fourth class. I mean, the second week classes, I missed that, and I couldn't find in the community. And I will send a message in the private message to you. If is it possible to you send me the link of that community, that message, okay? Because I couldn't find it personally. And another question is, I had a problem in topological link prediction library. I mean GDS library, because I wanted to test the algorithms, the prediction algorithms, but I got an error, and I don't know how to solve that. I need to install a. Do I need a? Do I need to install some
Yeah.
plugins
So
to apply that? Yes, am I right?
yes. So what you said is correct. So you need to install GDS plugin. Like once you start your Neo4j in your right hand side, you can see look about like different types of plugins will be there, updates will be there. So you can just click on the plugins and just install like a GDS plugin. So that's more than enough. So it will be running automatically. Yeah.
Okay, so
What was the name of that plugin?
So it's GDS, Graph Data Associate.
DDS.
Yeah.
DDS. Okay, thank you. I had the same issue as well.
Oh, okay.
yeah, I've downloaded and I've installed in the project, you know, the database plugin section, but I couldn't, but I wasn't successful to run my code. Even I had some errors. Okay, but I
Yeah.
can check another time. But if is it possible to you, I will send a message after recheck that, and if you have time, help assist me to continue the class and continue the codings. Okay.
Definitely, and definitely. And you can, if you want, you can share right now also. We can look it. So it's no worries. We have like another like 11 to 12 minutes time is there. We can
Oh,
go.
okay. Okay, I can share a screen now. Now it's disabled for me to
Okay.
share
Definitely. Yeah.
screen.
Yeah.
Okay. Oh no. I need to restart the Zoom because
Yeah.
I got access to it. Okay, I can send the photo to you after recheck. Okay.
So you can share me the screenshot as well. So no worries at all. So I'll be
I need to
there.
close my Zoom application and start again. This is why I couldn't share right now.
No worries. No problem. No problem. You can share the screenshot in our Xedar community page. So I'll be available online and I can respond to you.
Okay. Thank you.
Thank you, Satatri. Yeah.
Thank you very much. I'll find out where we add the plugins as well, because I did have the same issue as well. So I was wondering, same thing.
Thank you, Jean.
Okay. Thank you very much.
Have a nice day.
Have a nice day. Bye bye.
Cheers. Thank you. Bye. Bye.